The Pilgrim 1 spacecraft of NASA currently holds the record for the greatest distance traveled by any human-made object. It has fascinated people worldwide for nearly 50 years. Voyager 1 has been transmitting vital data ever since its launch, from the furthest parts of space, expanding humanity's understanding of the universe. However, the spacecraft's ongoing transmissions have recently encountered bizarre anomalies. These enigmatic signals have baffled scientists and sparked widespread discussion, raising a compelling question in the scientific community. Are these strange phenomena mere malfunctions, or are they signs of something more significant, even extraterrestrial? Join us on our journey as we examine these perplexing signals and investigate what might be concealed within the vastness of space. Humanity's desire to explore the uncharted has always been the driving force behind space exploration. This deep-seated curiosity led to the creation of ambitious missions like Explorer 2 and Pioneer 1, among the most daring space expeditions of their time. On August 2, 1977, Explorer 2 was launched from NASA's Kennedy Space Center, marking the beginning of a new era in space exploration. Shortly after, on September 5, 1977, Explorer 1 followed, embarking on a journey that would eventually take it beyond the outer planets and significantly alter its orbit. Each of these spacecraft had a purpose. Weighing approximately 120 kilograms, about the weight of a small car, they traveled in different directions at varying speeds. On December 15, 1977, a key milestone was reached when Explorer 1 outperformed its sibling in distance traveled due to the different paths they had taken. Since then, Explorer 1 has proven to be an invaluable instrument, offering insights that have reshaped our perception of the universe. Before diving into its most recent groundbreaking findings, let's revisit some of its earlier major accomplishments. In 1978, while positioned roughly 265 million kilometers from Earth, Explorer 1 captured detailed images of Jupiter. By January 1979, it had completed a remarkable 100-hour mission, producing a time-lapse video showcasing Jupiter's rotation. This series of 3,750 unprecedented images revealed chaotic atmospheric patterns and intricate details. Additionally, the spacecraft discovered a previously unknown ring encircling Jupiter and 2 new moons, significantly improving our understanding of the gas giant's complex system. To ensure a safe journey and avoid potential collisions with Titan, a moon of Saturn, the spacecraft executed several correction maneuvers. Following that, the mission's focus shifted beyond our solar system, heading into interstellar space. Traveling at an astonishing 325 million kilometers per year, Explorer 1 set off in January 1990 to explore the space between stars. During this phase, it achieved several remarkable milestones, including the discovery of 4 additional moons, Mimas, Enceladus, Tessis, and Rhea, and captured one of the most iconic images of space. On February 14, 1990, from approximately 6 billion kilometers away, Explorer 1 took its famous family portrait, showcasing stunning images of the inner planets. This collection of 60 photos was added to the spacecraft's portfolio, which also included 670 images taken during its Neptune flyby. Meanwhile, Explorer 2 also achieved impressive milestones. It recorded the highest wind speeds ever documented in the solar system, 13,100 meters per second, on Neptune, providing scientists with valuable data about the planet's distant atmosphere, and Triton, its moon. Triton displayed ice volcanoes that released nitrogen gas and frozen particles up to 5 kilometers high, offering a fascinating new view of the moon's surface. These extraordinary discoveries have greatly enhanced our knowledge of the dynamic environments at the solar system's outer edges. The contributions of Explorer 1 and 2 have been nothing short of groundbreaking. Their missions unveiled previously unknown details about the moons of Saturn and Jupiter, bodies once thought to be dormant. These findings revolutionized our understanding of their geophysical activity. Explorer 2 made history by becoming the first spacecraft to fly by both Uranus and Neptune, an achievement yet to be repeated. NASA employed innovative strategies to extend the mission's lifespans, such as shutting down non-essential systems to conserve power. The missions are expected to continue until 2030, ushering in a new era of exploration and discovery. Explorer 1 and 2's designs showcased cutting-edge engineering. Built for slow rotation to reduce image blur, they sent back detailed visuals even before reaching other planets. Early images of Jupiter revealed swirling clouds and the Great Red Spot, a massive storm that has long intrigued scientists. But the most exciting discovery came with active volcanoes on Io, one of Jupiter's moons. Instruments detected unusual signals, later confirmed by images of massive volcanic plumes and surface eruptions, some 1,000 times more powerful than Mount St. Helens. As the spacecrafts neared the end of their planetary missions, they slowed to conserve energy and transition to their interstellar phase. Mercury and Mars were not captured due to technical limitations, but NASA later launched other notable missions like Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 became the most distant spacecraft, surpassing Pioneer 11. However, Explorer 1 continued its journey, eventually entering interstellar space on August 25, 2012. The success of these missions was largely due to the innovative use of gravity assist maneuvers, a technique that allowed the spacecraft to accelerate using the gravitational pull of planets, conserving fuel. For instance, Jupiter's massive gravity was precisely harnessed to avoid trajectory deviations and propel the spacecraft farther. Explorer 2 similarly utilized gravity assists from Jupiter and Saturn to reach Neptune and Uranus, proving the technique's effectiveness. These results continue to yield exciting new insights, especially as scientists investigate the recent anomalies detected by Explorer 1. These spacecraft have not only advanced our understanding of the solar system but have also ventured beyond its boundaries, exploring the unknown. Their discoveries, new moons, rings, planetary atmospheres, and magnetic fields, have enriched our comprehension of our cosmic neighborhood. Moreover, these missions included a cultural component, the Golden Record, a message designed to communicate Earth's story to potential extraterrestrial civilizations. It includes greetings in 55 languages, music from diverse cultures, and natural sounds like thunder and whale songs, a message in a bottle expressing humanity's hope to one day connect with intelligent life beyond Earth. Both Explorer spacecraft carried sophisticated scientific instruments, including magnetometers, imaging systems, and plasma wave detectors. These provided crucial data on magnetic fields, solar wind, and planetary atmospheres. One of the most remarkable achievements was measuring the boundary of the heliosphere, the bubble of solar particles and magnetic fields surrounding our solar system. As Explorer 1 approached this boundary, it detected a divergence from the solar wind, offering vital information about Earth's protection from cosmic radiation. The spacecraft identified the termination shock, where the solar wind slows and becomes denser, and the heliosheath, where solar influence gives way to the interstellar medium. As we look toward the future of space exploration, the paths laid out by Explorer 1 and Explorer 2 serve as guiding lights for new missions that aim to push the boundaries even further. Missions like NASA's Artemis program, the James Webb Space Telescope, and planned journeys to Mars all build on the foundation created by these pioneering spacecraft. Their success has redefined what's possible, not only in terms of technological achievement but in our philosophical understanding of humanity's place in the cosmos. The data returned from the outer reaches of the solar system continues to challenge existing theories and inspire new ones. For example, the detection of unexpected plasma wave patterns and fluctuations in cosmic ray intensity has led some scientists to propose the presence of unknown interstellar phenomena, forces or interactions that we have yet to fully understand. Moreover, the longevity of the Explorer missions has demonstrated the extraordinary durability and foresight in their design. Built with technology from the 1970s, these spacecraft have survived the harshest conditions in space for nearly 5 decades. Their continued operation provides valuable lessons for the development of next-generation spacecraft intended for even more distant missions, including those aimed at exoplanets or the Oort cloud. The Voyager missions, Explorer 1 and Explorer 2 being alternate designations, have also inspired countless scientists, engineers, and dreamers around the world. They remind us that exploration isn't just about collecting data, it's about reaching for the unknown, embracing the mystery, and daring to imagine that we are not alone. What lies beyond the heliopause, where the solar wind ceases and interstellar space truly begins, remains a subject of intense curiosity. The strange signals picked up by Explorer 1 could be the result of interactions with unknown interstellar phenomena, or even glimpses of cosmic events like distant supernovae or black hole jets. While current interpretations lean toward natural explanations, the door remains open to possibilities that are both thrilling and humbling. At their core, these missions carry not just scientific instruments but also the hopes and questions of humanity. What are we doing here? Are we alone? Can we survive in the vast and often hostile universe? The answers may not come quickly, but the journey to find them is where meaning is often found. As we continue to track Explorer 1 and Explorer 2, now silent travelers in the dark, their presence serves as a reminder that Earth is just one small part of an immense and mysterious universe. And yet, through ingenuity and curiosity, we've managed to reach out, touch the stars, and leave a mark that may one day be found by another. Until then, their stories continue, etched in the silence of deep space, traveling further with each passing moment. The discovered magnetic field of Uranus is skewed in a way that makes it difficult for current theories of planetary magnetism to explain. Further action has been sparked by these discoveries. Investigations into the magnetic fields of other planets, and missions like these, have not only advanced scientific understanding but also piqued the public's interest in space exploration through breathtaking images, personal space, and distant planet stories. The missions of the spacecraft have influenced millions of people worldwide. Breathtaking photographs of Saturn's rings and Jupiter's volcanic moons have become iconic, encouraging the next generation of explorers and scientists. As the Explorer and Voyager missions continue to send back groundbreaking data, the ongoing exploration of space between stars presents extraordinary opportunities to comprehend the very foundation of the universe. While attention has traditionally been focused on the planets within our solar system, the shift in our solar system's direction has led to the study of interstellar space, revealing some unexpected facts about areas that are not influenced by the Sun. These areas were previously thought to be empty voids, but the complexity of these regions has been demonstrated through interactions and phenomena that challenge established scientific models. One of the most intriguing discoveries is the Voyager spacecraft's detection of the origin of cosmic rays from outside our solar system. These high-energy particles, which travel through space at nearly light speed, offer hints regarding the processes taking place in distant regions of the galaxy. By investigating the composition and energy of these cosmic rays, researchers hope to improve their understanding of the mechanisms operating in faraway stellar environments, such as the dynamics of galactic nurseries. In addition to Voyager 1 and Voyager 2, which venture further into space between stars, their instruments continue to monitor the density and movement of the interstellar medium, the gas-filled medium in the space between stars. Solar wind and dust interact in a way that affects the shape of the heliosphere, the protective bubble created by the Sun's influence. As the spacecraft pass through and approach this medium, they are providing crucial information that will enable scientists to better model the behavior of matter and energy in the vast distances that separate stars. In addition to exploring the interstellar medium, the Voyager spacecraft have had a major impact on our understanding of magnetic fields. Both Voyager 1 and Voyager 2 have provided detailed measurements of magnetic fields in the space between stars, offering insights into the nature of these fields and how they influence the environment around them. These breakthroughs could lead to new findings in our understanding of the behavior of magnetic fields in other galaxies, fostering a more comprehensive understanding of the cosmic forces at work across the universe. The ongoing investigation of our solar system's outermost regions and beyond is not just expanding our knowledge of space but also inspiring future generations of scientists and engineers. The famous photographs taken by the Voyager spacecraft, such as the iconic image of Earth as a pale blue dot taken from more than 6 billion miles away, serve as a constant reminder of our place in the universe. Together with the discoveries made by the spacecraft, these images have significantly influenced how we perceive our planet and its connection to the universe. The success of these missions has also paved the way for bigger and better future space exploration projects. With the technological advancements made during the Voyager and Explorer missions, the potential to send even more sophisticated spacecraft to the outer reaches of space is becoming increasingly feasible. Missions to distant exoplanets, the search for habitable worlds, and the exploration of other star systems are no longer just dreams but achievable objectives for the future of space exploration. Additionally, the information gathered by these spacecraft has far-reaching implications for understanding the conditions necessary for life to exist. By studying the composition of distant planets and moons, scientists have gained valuable insights into the factors that contribute to habitability, such as the presence of water in the atmosphere and the availability of organic molecules. Not only do these findings help in our search for a place to live outside the universe, but they also improve our understanding of how life on Earth may have originated. The partnership between engineers, scientists, and institutions around the world in these missions demonstrates the power of global cooperation in achieving common goals. As the Voyager and Explorer spacecraft move forward with their journeys into the unknown, they carry with them not only the hopes and dreams of humanity but also the collective spirit of discovery that motivates us to go further into the reaches of the cosmos. The anomalies discovered by Explorer 1 and various other spacecraft also highlight the importance of continued vigilance and adaptability in space exploration. Due to advancements in technology and the subject of new discoveries, it is essential to maintain adaptability when interpreting data from these distant spacecraft. The strange signals that have been recently discovered may represent new and unanticipated events that have never been observed before, pushing the limits of our comprehension. In conclusion, the investigation of space is an ongoing journey that continues to reveal new mysteries and challenge our conclusions. The Explorer and Voyager missions have changed our perception of the solar system, space between stars, and the entire universe. As these spacecraft continue their extensive journeys, they will remain within human observation's reach and, without a doubt, continue to provide important information that will shape space exploration in the future. The repercussions of these missions for future generations will inspire explorers to venture into the unknown, driven by the same curiosity and desire to comprehend the universe that fueled the exploration of space by humanity right from the start. As these missions continue, they will also highlight the need for continued investment in space exploration. The discoveries made by Voyager, Explorer, and other spacecraft are just the beginning of what promises to be a long and exciting journey into the unknown. Each new discovery opens up new avenues of inquiry, presenting both challenges and opportunities for further exploration. The knowledge we gain from these missions has the potential to reshape our understanding of the universe and our place within it. Moreover, the role of international collaboration in space exploration cannot be overstated. The collective effort of scientists, engineers, and institutions from around the world is essential to tackling the vast and complex challenges of space exploration. This global partnership not only accelerates the pace of discovery but also ensures that the benefits of space research are shared across borders. By pooling resources and expertise, we can push the boundaries of what is possible in our exploration of space. Looking ahead, the future of space exploration is full of possibilities. The technologies and methodologies developed during the Voyager and Explorer missions have laid the groundwork for future spacecraft and missions. As new challenges arise, scientists and engineers will continue to innovate, developing tools and techniques that will enable humanity to venture even farther into the cosmos. Whether it's exploring the depths of interstellar space, studying the surface of distant exoplanets, or seeking signs of extraterrestrial life, the next chapters in space exploration promise to be just as groundbreaking as those that have come before. In the end, the exploration of space is more than just a scientific endeavor. It is a testament to humanity's innate curiosity and desire to understand the universe. Each new mission, each new discovery, brings us one step closer to answering the fundamental questions about our existence and our place in the cosmos. The journey may be long, and the path may be fraught with challenges, but the rewards, both in terms of knowledge and inspiration, are immeasurable. And as we look to the future, we can be certain that the legacy of the Voyager and Explorer missions will continue to inspire generations of explorers, scientists, and dreamers for years to come.